Magnets. How do they work? Today we will be learning how to use the PASPort Magnetic Field Sensor in order to investigate this question a little further.
Water, fire, air, and dirt.
Awesome.
Magnets, how do they work?
The PASPort Magnetic Field Sensor works by measuring magnetic field flux density along the axis of its probe in units of Tesla, millitesla, or Gauss. You may vaguely remember learning about magnetic field in high school physics as the time when you silently looked at your hands, wondering what the difference was between the left-hand rule and the right-hand rule. They help with discerning the direction of current, motion, and field when working with motors and generators. The left-hand rule is used for electric motors, and the right-hand rule is used for electric generators. The right-hand grip rule, or the thumb rule, is used to predict the direction of magnetic field from a wire. Now that you remember how to determine the vector of the magnetic field, you'll need to know how to calculate the strength of the magnetic field. Magnetic field is a vector quantity, so it's described using both strength and direction. Magnetic fields occur whenever a charge is in motion, and it can be calculated using the following equation. Magnetic field strength at the distance d is equal to the permeability of free space multiplied by the current and divided by 2 pi in the distance from the wire. I won't explain how to calculate this in too much detail, as I'm just wanting to introduce or refresh the concept before explaining how to use the PASPort Magnetic Field Sensor. The range of sensitivity for this sensor is plus or minus 1000 Gauss, so this is ideal for measuring the field strength of bar magnets, or electromagnets, the field strength of a solenoid, or the field strength of a Helmholtz coil. Now that we remember the difference between our lefts and rights, and we've reviewed the equation for magnetic field, let's learn how to use this thing. You'll need the PASPort Magnetic Field Sensor in the Spark Science learning system. Plug the sensor into one of the input ports, like so. Power on the Spark, and wait for it to start up the data collection software. It'll take a moment for this to boot up. Once it's booted up, you'll be taken to the main screen where it shows the current reading in Gauss. Tap the current reading and you'll be taken to a display showing an empty graph. Pressing the play button on the bottom left will begin data collection. Be sure to measure along the axis or parallel to the probe. You must measure along the axis of the probe because this works using the Hall effect. In a Hall effect sensor, a thin strip of metal has a current applied along it. In the presence of a magnetic field, the electrons in the metal strip are deflected towards one edge, producing a voltage gradient across the short side of the strip, which is why it's necessary to measure along the axis or parallel to the probe. Once you're done collecting data, press the button in the bottom left again, and you're done. You've successfully used the PASPort Magnetic Field Sensor to collect and record data. All that remains is the interpretation of that data. Unfortunately, in this video, we won't be able to answer that age-old question of magnets, how do they work? But you should have the tools and the knowledge to figure it out on your own. Thanks for watching.